Hello everyone and welcome to video 10 of Module 2 Inquiry Question 2. And today we're looking at mole ratios. So this is where things start to come together. All the calculations you've done start to get their practical applications. So again, this is a really important part that we need to work with and develop that understanding. And this is, like I said, also the practical applications where we really have an industry application where you can see how chemistry actually does have its role. So when we are looking at mole ratios, we're obviously making a ratio of the moles in our chemical equation. And so we are looking at the ratios of the coefficients, the number in front. And this is what stoichiometry is. And this is all underpinned by the law of conservation of mass. So it's really important that matter and mass is not created nor destroyed, and neither are those atoms. So it's really important that we have got that balanced equation. Once we've got that balanced equation, we can use the mole ratio, so the coefficients in front of the formulas that you have, to predict the amount of a product that will be formed and how much reactant might be needed to make that amount of product. So you can think in industry where they're perhaps making ammonia, like they do over at Orica, and for that they're going to need nitrogen and hydrogen. Well, what amounts of nitrogen and hydrogen do they put in to get the product they've got? Put too much of one other in, they've got excess. Put not enough, the reaction won't produce as much as they want. So by putting the right amount in makes the reaction a lot more efficient. So if we have a look here, and I'll just move me out of the way. So when carrying out calculations, we have to be really clear in our working out and telling the person that's looking at your calculations, not just a marker, but if you're working as a chemical engineer or as a scientist in a lab, you need to tell people who are looking at your work what it is that you're calculating. Otherwise, they just see a whole range of numbers. So one of the reactants or products will be your known. You'll know how much you're producing or how much you're putting in, and therefore the other one that you're wanting to find out will be considered to be your unknown. And if we put the moles of our unknown over the known and put the coefficients there as well, we can work out how much we'll have. So for example, if the coefficients of the unknown is 3 to the known 1, and I know that I've got 6 moles of my unknown, then I know I'll have 2 moles of my known. But it sounds a lot easier if we do it in a calculation. Okay, so we've got our 4 hydrogens here and we've got our 4 hydrogens here. They're balanced. I've got my 1 carbon here, my 1 carbon here. It's balanced. So I'm now looking at the oxygens. On this side, I have got 3 oxygens, and on this side, I've got 4. So I look and I go 1. I need 3. Here's 1. And of these ones here, I need to get 3. So one way we can do that is by doing our 3, our 3 over 2, which then gives you 1 mole of this methanol producing using up 3 over 2 or 1.5 moles of oxygen with 1 mole of carbon dioxide producing 2 moles of water. We've talked before that we don't tend to use fractions, so in which case I would then go through and double everything, in which case that would then become a 2. I'd get rid of that and just leave it. It's 3, make that a 2, and that would become a 4. Now just I always double check 2 carbons, 2 carbons. I've got 8 hydrogens over here. I've got 8 here. I've got 4 oxygens plus 4, which is 8. Here I've got 6, and there's 2, 7, 8, so it is balanced. This one's not an easy one to have started with. But anyway, so the question comes back and says I've got 0.375 moles of methanol, and how many moles of carbon dioxide are produced. So you can see here that the ratio is 2 to 2. So again, I tend to kind of go, 2 moles of CH3OH to 2 moles of CO2. So therefore, I could say 0.375 moles of CO2 produced. Don't just write 0.7375 moles. Tell them again of what's being produced. A good little diagram to help you kind of make sense of what you're trying to work out and how to do it in the questions that you're going to be using is given here. So say, for example, we know the mass of the substance, the mass of the substance that we have over here. We know the mass. I know I've got 3 grams of something. Using this formula, I can work out the moles. So now I've got the moles. Once I know the coefficient ratio, if I know I've got 1 mole of carbon dioxide produces 2 moles of water, then I know I'm going to have double the amount of my unknown. So I can use that to come here. Then and once you know your moles of your unknown, again, using your moles is equal to mass over molar mass, you can work out how much in terms of grams you have of your unknown. So I always start to look in questions. They're giving me how many the mass of something. Oh, they've given me the moles of something else, and I'm immediately starting to think of this diagram and what is it that they're wanting me to calculate. And it's always good to write all your knowns down straight away so that it starts to become clear. We'll do loads of practice of these in class. I'm sure you're looking forward to it. I'll see you then. Bye-bye.